Okay. In the previous class, we have looked at the properties of Z transform. Now we will use certain problems by using Z transforms and solve the problems by using properties of Z transform. Okay. So take the first problem. X of n is equal to 3 into 2 power n u of minus n. So here you should not use the basic Z transform formula. You should use the properties of Z transform and solve the problem. So what I will do, look here in this one, he has given u of minus n. U of minus n in this one. So there is only one term with minus. So what I should do is, I know the formula for Z transform of a power n u of n. A power n u of n. Here okay, a power n u of n. So this is equal to 1 by 1 minus a z raised to minus 1. Here n and n both of them have the same sign, but here you have minus n and here you have plus n. Therefore I should convert these two in this form. So what I will do is, I'll write plus n as minus 1 raised to minus n into u of minus n. So 2 power minus 1 is 1 by 2 power minus n u of minus n. See here, this is also minus n and this also minus n. Now what I will do, I'll write the formula for a power n u of n. Okay, so a power n u of n z transforms to 1 by 1 minus 1 by 2 z raised to minus 1 mod z is more than 1 by 2. Okay, don't write the formula for 1 by 2 raised to minus n. Write the formula for 1 by 2 power n u of n. That z transforms to this much. So z mod z is more than 1 by 2. That is the ROC. Are you clear with up to this step? Any doubt you have? Is it clear to you? Any doubt? Till now it is okay? Any doubts, Sanjay? Now, what I will do is, I don't want the z transfer of 1 by 2 power n u of n, but I want the z transfer of 1 by 2 power minus n u of minus n. So, I'll write using the time reversal property, what I will do, 1 by 2 power minus n u of minus n, z transform with, here, I'll multiply with plus z, I'll multiply with z. So what happens? If you multiply with z, this becomes z. See here, a power minus n, minus n. I'll multiply with z. Excuse me, 1 by 1 minus 1 by 2 z, where z mod z is less than 2. So when inverting, time inverting. So more than 1 by 2 transforms 1 by 2 raised to minus 1. That is 2. So what you are doing actually exactly, wherever z raised to minus 1 you have, that is gets replaced by plus z. Z power minus 1 translates to z power plus 1. That's why I have z transform as 1 by 1 minus 1 by 2 z. So that's the time reversal property. Now actually what you require is 3 into this much. Now until now I obtained the z transform of this one. So by using 3 into 1 by 2 raised to minus n u of minus n, this much z transform is available. Now I'll use the last property, that is multiplication by the number, that is 3. So multiply this value by 3. It is not z, it is 3. 3 by 1 by 2 z, by retaining the ROC mod z less than 2. Any doubt till now? Any doubt?
No, sir.
Okay. Once you understood, now we will go to next problem. X of n is equal to n square into 1 by 2 power n u of n minus 3. Now once again notice u of n minus 3. So I should convert the problem into a power n minus 3 u of n minus 3 as I did in the previous case. So what I will do, see here, n square is retained as it is 1 by 2 power n minus 3 plus 3 I'll write. So that minus 3 plus 3 will get cancelled. You are going to get same n. Or then 1 by 2 raised to n minus 3 into 1 by 2 raised to 3 u of n minus 3. Is it clear? Clear to you? Okay. Now 1 by 2 raised to 3 is a constant. I'll write it as 1 by 8. And this one is n square. And this one is 1 by 2 raised to n minus 3 u of n minus 3. So once again, I will use a formula 1 by 2 power n u of n z transforms into 1 by 1 minus 1 by 2 z raised to minus 1. So mod z more than 1 by 2. See here, a power n u of n translates to 1 by 1 minus a into z power minus 1, where mod z is more than a. The a is 1 by 2 here. So this much I have obtained the z transform. Now I don't need only 1 by 2 power n. I need the z transform of 1 by 2 power n minus 3. Therefore, I'll use the time shifting property. Therefore, 1 by 2 power n minus 3, u of n minus 3, z transforms into whatever is the previous z transform, you retain 1 by 1 minus 1 by 2, z raised to minus 1. Multiply by z power minus 3. If it is minus 3, multiply by minus 3. If it is plus 3, multiply by plus 3. So z power minus 3 into 1 by 1 minus 1 by 2 z raised to minus 1, retaining the ROC. But only one thing is, since you added 1 by z power 3, so it generates a pole at z equal to 0. That you have to add extra. Okay. So I'll write 1 by z power 3 into 1 by 1 minus 1 by 2 z raised to minus 1, or z cube minus 1 by 2 z square. Okay, z cube minus 1 by 2 z square. So used the basic property of z transform, and I used the time shifting property of z transform, and I got this term. Till now, any doubt? Any doubt till now? Shall I proceed? Now, since you have, let us n square, look at the term n square into this one. I need to use the differentiation property. The differentiation property should be used one n at a time. Don't write n square into this much. Now the z transform of this much is already available. First, I'll use multiplication by n property. So what is the multiplication by n property? Z transform of x of n is x of z. Then z transform of n into x of z, n is transforms into minus z into d by dz of x of z. That is, so minus z into d by dz of, what is x of z here? 1 by z cube minus 1 by 2 z square. Okay, so take the differentiation. How do you do the differentiation? So derivative of 1 by z. What is the derivative of 1 by z? Minus 1 by z square. Minus into minus becomes plus. You have z as it is, 1 by z cube minus 1 by 2 whole square into derivative. What is the derivative of this z cube? 3z square minus derivative of z square is 2z. 2 cancels a z. So what's completely remains is multiply this one by z. I have 3z cube minus z square divided by z cube minus 1 by 2 z square whole square. Up to this much is clear to you? Or any doubt you have?
No, sir.
Okay. Now remember, when there are n square or n cube is involved, one n should be taken at a time. Don't take n square and write minus z into d by dz whole square. That is not allowed. Each n should be taken separately. So now out of n square in the problem, look at the problem here. It is n square. I taken one n at a time and use this one. This is my answer. Now once again I use the property, differentiation property. So Once again, minus z into d by dz of this value, whatever previously I have obtained. That is 3z cube minus z square divided by z cube minus 1 by 2 z square whole square. Let us see the differentiation. Do the differentiation very carefully. Minus z I retained. Derivative of u by v. What's the derivative of u by v? V into derivative of u minus u into derivative of v divided by v square. See here, first term z cube minus 1 by 2 z square whole square. This is the first term I have written as it is into derivative 9 z square minus derivative of z square is 2z minus the first term 3z cube minus z square into the derivative of this one. Derivative is 2 into z cube minus 1 by 2 z square into derivative of this one 3z square minus 1 by 2 into 2z, that is z. So u into derivative of v minus v into derivative of u is over divided by denominator square, that is z cube minus 1 by 2 z square whole to the power 4. So when you have this one, see here z cube minus 1 by 2 z square, z cube minus 1 by 2 z square is common between both the terms, that cancels with one of the terms. What remains is only z cube minus 1 by 2 z square into 9z square minus 2z minus 2 is 2 are written here, 3z cube minus z square into this term is cancelled because of taken common into 3z square minus z. Okay, so one term cancels in the denominator, remaining thing is z cube minus 1 by 2 z square whole cube. Once I done this one, now in the first term, in this term, what is common? Z square. Z square is taken this side. In the second term, see here z square and z, I can take z common, so it has become z square. So totally z into z, z square, and this z square, z to the power of 4, it will become, look here, same z square here and same z here. So I taken z, totally z cube will become common from both the terms. Similarly, in the denominator I have z square. Okay, so in the z square I taken common. What remains in the denominator is z only minus 1 by 2 whole cube. Any doubt in this step?
No, sir.
Okay, once you have done this one, z to the power of 4 divided by z to the power of 6, I have only z to the power of 2 in the denominator. Now multiply each of the time, z into 9z, 9z square minus 2z minus 9 by 2z plus 1 by 2 into 2 is plus 1 minus 2 I retained 3z minus 1, 3z minus 1, 3z minus 1 whole square, that is 9z square minus it minus plus 1 minus 2 into 3, 6z. So add the like terms, 9z square minus 18z square, that is minus 9z square, minus into minus is plus 9z square. Next, minus 2z minus 9 by 2z and plus 12z. That gives me plus 5.5z, multiply by minus 1, that gives me minus 5.5z. Now and this one is plus 1, only one term, minus 2, so it gives you minus 1 multiplied with minus 1 gives me plus 1, and here I have in the denominator only z square and z minus 1 by 2 whole cube. Okay, therefore this is your final answer. So finally at the end, x of n is this much, this z transforms into 1 by 8 into this term. Okay, where is 1 by 8 is the first term. This 1 by 8 multiplication I'm using, that is by a constant, I'm retaining the constant, and remaining these terms I'm multiplying and I'm using this one. Is it clear to you?
Yes, sir.
Okay, this gives you 6 marks, single problem it gives you 6 marks, do it carefully. Okay, now let us go to this one. Now let us say x1 of n is 1 minus 2 1 and x2 of n is equal to u of n minus u of n minus 6. Okay, so what is required is convolution of x1 of n and x2 of n. What happens when you convolve x1 of n and x2 of n by using z transform? So what we will do is take x1 of n, obtain x1 of z. What is x1 of z? X of n into z power minus n from z equal to 0 to 0, 1, 2. N equal to 0, 1, 2. So x1 of 1 into z power 0 minus 2 into z power minus 1 plus 1 into z power minus 2. That's what I written. See here, this can be written as 1 minus 2x plus x square. See here, 1 plus x square minus 2x. That is x minus 1, 1 minus x whole square. Instead of x, whatever I have is z minus 1. Therefore, I written it as 1 minus z minus 1 whole square. Next one, u of n minus u of n minus 6. What is u of n? U of n is equal to 1 from n equal to 0 till infinity. And u of n minus 6 is equal to 1 from n equal to 6 till infinity. So when you subtract these two signals from 6 to infinity, you are going to get both the signals cancelled. The remaining signal is only from n equal to 0, 1, 2, 3, 4, 5. That is totally 6 samples, each one of them 1. Therefore, I have 6 ones in this one. That's how I obtained x2 of n. Now, how do I obtain x2 of z? Summation n equal to 0. This point is n equal to 0. 1, 2, 3, 4, 5. That's the maximum limit is 5. X of n into z power minus 1. So, I'll write 1 plus z raised to minus 1 plus z raised to minus 2 plus z raised to minus 3 plus z raised to minus 4 plus z raised to minus 5. Thus, I written as x1 of z. Or another way you can write it as this is sum to n terms of a GP. So summation, this one can be written as 1 minus z raised to minus 6. That is 1 into z power minus 1 can be written as 1 minus z power minus 6 divided by 1 minus z raised to minus 1. This also can be written in this format. Once I obtain x1 of z and x2 of z, what is the formula saying? Convolution of x1 of n with x2 of n in the time domain converted into multiplication in the z domain. That is x1 of z into x2 of z. What is x1 of z? This is 1 minus z raised to minus 1 whole square. This is your x1 of z. x2 of z is 1 minus z raised to minus 6 divided by 1 minus z raised to minus 1. So out of which 1 minus z raised to minus 1 gets cancelled. What remains is only 1 minus z raised to minus 1 and 1 minus z raised to minus 6. So multiply them. 1 into 1, 1 minus z raised to minus 6. This are written minus z raised to minus 1. This are written here minus into minus 6 plus z raised to minus 7. So this is n equal to 0, n equal to 1. So remember, how do you write x of n? Write the coefficient of z terms. So z power 0 is 1. Z power minus 1 is minus 1. What is the coefficient of z power minus 2? Anybody? What is the coefficient of z power minus 2?
0.
0. Z power minus 3 is not there. Z power minus 4 is not
0.
there. Z power minus 5 is not there. Therefore, you should write 0. Okay. Z power minus 6 you have minus 1. Z power minus 7 you have plus 1. That solves your convolution. So it is quite easy to perform convolution in the set domain. Instead of performing laborious convolution in the time domain, what we have seen in the module 2, it's quite easy to perform convolution in the Z domain. Okay, now I'll go to the next problem. Once again, I'll have x of n is 1 by 3 power n minus 4 into u of n minus 2 to obtain the Z transform. Now look at u of n minus 2. You should bring the n minus 2 here also. So what I will do, I'll rewrite this as x of n is equal to 1 by 3 raised to minus 2. Only minus 2 will take it this side. So how 1 by 3 raised to n minus 2 into u of n minus 2. Look here, this n minus 2 and this n minus 2 should match. Then only you'll be able to solve the problem. Now I'll apply the basic known formula. Z transform of a power n u of n transforms into 1 by 1 minus a z raised to minus 1 mod z is more than mod a. What is a here? A is 1 by 3. So I'll apply the formula and I'll write that is equal to 1 by 1 minus 1 by 3 z raised to minus 1. What is your ROC? ROC is mod z more than mod a. That is a is 1 by 3. Therefore mod z is more than 1 by 3. So this is your Z transform, this one, 1 by 3 power n u of n. Now what I will do, I should apply the time shift property. So x2 of n is nothing but x1 of n by 2, say n minus 2. So that is time shifted by 2 time minutes. So x2 of z is equal to, what I will do, I'll retain the old z transform x1 of z, but I'll multiply with z power minus 2. Because you are shifted by minus 2, I'll multiply by minus 2. That is z power minus 2 into 1 by 1 minus 1 by 2 z raised to minus 1. Once I do this one, see here, I'll become multiply and divide by z. I'll get z power minus 1 z minus 1 by 2. Any doubt at this step? Any doubt?
No, sir.
Okay. Mod z is more than 1 by 3, that remains unchanged, not changed the ROC. Once I did that one, finally what remains is, see here in the problem, I had solved this one. This is complete. Only 1 by 3 raised to minus 2 is remaining. So I'll just multiply this one. 1 by 3 raised to minus 2 into this one is nothing but 1 by 3 raised to minus 2 is retained, multiply by x2 offset. What is 1 by 3 raised to minus 2? 3 raised to 2. 3 raised to 2 is 9. 9 into x2 of z. 9 into z to the power of minus 1 divided by z minus 1 by 2. Mod z is more than 1 by 3. This solves your problem. Have you understood the problem?
Yes, sir.
Okay. Now, look into the another very simple problem. X of n is equal to n into a power n u of minus 1, u of minus n. Now, once again, what I will do, I know only the formula for a power n u of n. What is the formula for a power n u of n? That is, z transforms into 1 by 1 minus a z raised to minus 1. That is, I'll take z upside, multiply and divide by z. So, how z by z minus a. Mod z is more than mod a. This is the formula known to me. So, what I will do is, that x1 of n is equal to a power minus n into u of n I'll take. So, a power minus n becomes 1 by a power n u of n. So, this z transforms into x1 of z is equal to z by z minus 1 by a. So, mod z is more than 1 by mod a. Why I taken as 1 by a power n is because I should get minus n. I'll write a power minus 1 raised to minus n. See here, ultimately, why I should take a power minus 1? Because it is not mentioned in the problem. You may be thinking, what actually happens is u of minus n ultimately I want. So when I'll get a power minus n, u of minus n I can write. So to write a power minus n, I'll write a power minus 1 raised to minus n. So that's why a power minus 1 is written as 1 by a whole power n. 1 by a power whole power n it is written. Now what I will do, I will apply the time reversal formula. This is 1 by a power minus n. So minus n, here also it becomes minus n. So I'll write x1 of minus n. So what happens? What is your formula? x2 of z is nothing but x1 of z only. Wherever z is written, replace it by 1 by z. So this is your z transform. This z gets replaced by, see here, this z gets replaced by z raised to minus 1. This z gets replaced by z power minus 1, and remaining constant minus 1 by a retains unchanged. What's your ROC? Z power minus 1, whatever instead of z I have z power minus 1 more than 1 by a. Here I have z more than 1 by a, replace z by z raised to minus 1. That gives me z more than mod z raised to minus 1 more than 1 by a. That means that z is more than a. Okay, 1 by z is more than 1 by a. That is, z is less than a. 1 by z is more than 1 by a. That means z is less than a. Now, once you have this one, you obtain the z transform of a power n u of minus n. But n is remaining. Look at this n. So what I will do? I will use multiplication by n property. So what's the transform saying? If you multiply, if x of n equal to n into x2 of n, z transforms into x of z is equal to this z transform gets differentiated minus z into d by dz of x2 of z. So what is your x of z? X of z is equal to, I'll write z raised to minus 1 divided by z raised to minus 1 minus 1 by a into minus z into d by dz. Any doubt in this step? Any doubt till now?
No, sir.
Okay. Once you understood this one, so I'll simply take the derivative. So first function into derivative of second one minus second one into derivative of first one divided by denominator square are done. This differentiation yields the x of z. Now, what is the ROC? ROC is mod z less than mod k. That's what is the difference between the previous problem and this one. So this should be your ROC. Okay. Now, let us go to the next one. X of n is equal to 2 power n sine of pi by 4 n u of n. Now, in the previous section, the previous class, we have solved sine of omega naught into u of n. What is the z transform? Z into sine of omega naught divided by z square minus 2z cos of omega naught plus 1. Mod z is more than 1. So, same formula you apply this way. Wherein what is the difference between these two? Omega naught equal to pi by 4. Put omega naught equal to pi by 4 in this equation. I have sine of pi by 4. Sine pi by 4 is 1 by root 2 into z divided by z square minus 2z cos of pi by 4. Cos pi by 4 is 1 by root 2 plus 1. I got the z transform of sine of pi by 4 n into u of n. This much is over. Now, multiplication by exponential property I'll use. So what happens if x of n equal to a power n x1 of n, then if you z transform, so whatever x of n of z is there now, replace it by x of z by a. So if it is 2, this will become z by 2. If it is 3, it will become z by 3. So, but ROC, instead of mod z more than 2, 1, z gets replaced by z by 2. That is mod z more than 2. That's the only change. Okay, a power n x1 of n gets transformed into x of n of z only, but z gets replaced by z power a, and a should not be 0. You should not multiply by 0 power n. That is not allowed. Okay. Now what I will do? I'll write 1 by 2, 1 by root 2. Wherever z is there, I'll replace z by 2. This z becomes z by 2. Same way z square becomes z by 2 whole square minus root 2. Z becomes z by 2 plus 1. That is simplified. This gives me root 2z divided by z square minus 2 root 2z plus 4, where mod z is more than 2. So z by 2 is more than 1. There is mod z is more than 2. That solves your problem. Okay. Any doubt till now?
No, sir.
Okay. Now, once again, I'll take a problem of convolution. I'll give two sequences x of n equal to delta of n plus delta of n minus 1 plus 4 into delta of n minus 2 and h of n equal to 1 by 2 power n from 0 less than or equal to n less than or equal to 2 and 0 otherwise. These two sequences are given and you have to convolve this x of n and h of n and obtain the convolved result. So what I will do, what is the result of convolution? How do I perform convolution? Y of n equal to x of n convolved with h of n. So y of z is equal to x of n transforms to x of z, h of n transforms to h of z. So y of z is equal to x of z into h of z. Now first obtain x of z. X of z, what's the formula? X of n into z power minus n summation for all values of n. So write it. Summation for all values of n, delta of n plus delta of n minus 1 plus 4 into delta of n minus 2 into z power minus n. Okay. So what I will do? What is delta of n? Delta of n exists only at n equal to 0. Therefore, put n equal to 0 here. If you put n equal to 0, delta of n becomes 1 into z power 0. That I written as the first term. Where delta of n minus 1 will exist? It will exist only at n equal to 1. So I'll write z power minus n at n equal to 1 plus 4 into this will become delta of n minus 2, that is z power minus n existing only at n equal to 2. So this is equal to z power 0 is 1 plus n equal to 1 if I write z power minus 1 plus 4 into z power minus 2. So this is the result of x of z. Any doubt in this problem?
No, sir.
See here, remember one thing, I think the beginning we have solved delta of n minus k transforms to z power minus k. That's all. If it is n minus 1, it becomes z minus 1. If it is n minus 4, it becomes z raised to minus 4. That's all. Okay. Similarly, h of z, it is n equal to 0 to 2, 1 by 2 power n, z raised to minus 1. So I written 1 by 2 z raised to minus 1 whole raised to n. So, so what happens? Put n equal to 0. So I'm not going to evaluate this summation. I'll write put n equal to 0. So a power 0 becomes 1. That's the first term. Second term, n equal to 1, 1 by 2 power z raised to minus 1. Third term is 1 by 2 z raised to minus 1 whole square. That is 1 by 4 z raised to minus 2. So you have h of z you have and x of z you have. So what I will do, I'll use both of them, h of z and x of z, I'll multiply them. So 1 plus z raised to minus 1 plus 1 by 2 z raised to minus 1. Look at here, 1 into z raised to minus 1 plus 1 by 2 into z raised to minus 1. That gives you 3 by 2 z raised to minus 1 plus, what are the terms with z raised to minus 2? 1 into 4 z raised to minus 2 plus 1 by 2 z raised to minus 2 plus 1 by 4 z raised to minus 2. There are three terms which gives me 19 by 4 into z raised to minus 2 plus z raised to minus 3. 1 by 2 into z raised to minus 1. This term into 4 z raised to minus 2. That gives me z raised to minus 3 plus 1 by 4 into z raised to minus 2 plus into z raised to minus 1. That gives me 9 by 4 into z raised to minus 3. So only one term gives you 4 into 4 gets cancelled. Z raised to minus 2 into z raised to minus 2 gives me z raised to minus 4. So this is your final y of z. So obtain y of n. Now once again write the coefficient. This is 1. 1 gets transformed into delta of n. So 3 by 2 is retained. So delta of n minus k transforms into z power k, z power minus k. So minus 1 transforms into delta of n minus 1 plus 19 by 4 minus 2 transforms into delta of n minus 2 plus 9 by 4 into minus 3 gets transformed into delta of n minus 3 plus 1 as it is delta of n minus 4 because minus 4 gets transformed into this much. So minus 3 transforms here, minus 2 gets transformed here, minus 1 gets transformed here, and 0 got transformed into delta of n minus 0. So this solves your problem. So this is how you are going to obtain the convolution result of two sequences by using Z transform. Is it clear to you?
Yes,
Yes,
sir.
sir.
Okay, it's quite simple. You can solve these problems. I'll share this one to you. Okay, now one more problem we'll take. This is also quite simple. Find the initial value x of 0 and final value of the below Z domain signals. Okay, so it's a very simple problem, gives you 4 marks. So first consider x of z. X of z is given 1 by 1 plus 2 z raised to minus 1 minus 3 z raised to minus 2. Okay, what's the initial value theorem saying? X of 0 is obtained by using x of z by taking the limit as z tends to infinity. So x of n you don't know, but I want x of 0. How do I calculate x of 0? I'll consider your x of z as it is and I'll take the limit as z tends to infinity. So limit as z tends to infinity 1 by, so write 1 plus 2 by z minus 3 by z square. See here, I written 2 by z minus 3 by z square. Take z as infinity. Z as infinity, this becomes 0 and this becomes 0. What remains is 1 by 1. That becomes 1. That is your initial value. Now final value theorem. Final value also. So this is limit as z tends to 1. 1 minus z raised to minus 1 into x of z you have to obtain. That is limit as z tends to 1. 1 minus z raised to minus 1 you remain as it is and write your x of z. 1 by 1 plus 2 z raised to minus 1 minus 3 z raised to minus 2. So retain this one as it is, z raised to minus 1. Okay, see here, I'll multiply z raised to minus 1. This gives me z square minus plus 2z minus 3. So I'll multiply z power minus 2 here. So this becomes that multiplying both sides by z raised to minus 2, I get z raised minus 1 into z minus 1. Take it z raised to minus 1 outside. So you get z minus 1 into z raised to minus 1. In the denominator, how z raised to minus 2. So you're going to get this term. Otherwise, what you do? Multiply numerator and denominator by z square. So multiply by z square, what would happen? Z square minus z. That is z into z minus 1. In the denominator, z square plus 2z minus 3. Whichever approach you want, you can follow. So z square plus 2z minus 3, if you factorize, it will become z minus 1 into z plus 3. Once it becomes z minus 1 to z plus 3, these two terms will get cancelled and z by z plus 3. So once you give z equal to 1, what will happen? It will become 1 by 1 plus 3. That will become 1 by 4. Is it clear to you? Okay, this theorem you have to understand and solve the problem. Okay, so two more problems are solved in this one. I'll share the notes to you. You can go through it. So both the problems have the same method. Okay.